languages. So I thought what would be kind of fun, right, at the start of this session is to warm up the crowd, right? Because this is, you know, the Europeans are a little bit more conservative than the Americans, apparently, right? That's what everyone's been telling me. So, but I don't think so. I think I can get you guys to stand up and cheer about things, right? So what I thought is I would start off by showing you pictures of food, right? And you get to cheer for the food that you like the most. Right? And you'll see some cultural references here, right? So let's start off with this. What do you think? Yeah, too American. That's Canadian, actually, right? That's Tim Hortons. How about this? Huh? Yeah? A little bit better, right? It's bacon. Well, developers love bacon, right? Yeah? Hey, there we go. Yeah, we're warming up the crowd. All right, so that's some food to warm you up. The next thing I wanted to do was just kind of talk a little bit about programming languages, right? So I'll have a few languages here. You cheer for the ones that you like. Yeah? Yeah, he's getting no love these days, right? You know, that's Alan Cooper. Yeah? Brendan, yeah, a little bit. Yeah, there's a few. Yeah, you know. This guy, Bjarne? Oh! And, of course, that guy. Yeah, of course, everybody loves this guy, right? So, all right. That at least gives me kind of a flavor for what the audience is like, right? And certainly I've known about this for a while. This is a C# crowd. This is a .NET crowd for the most part, right? You know, certainly that we have here. And that shouldn't really be surprising. And I wanted to try and answer the first why question that we have here, right? Which is, why all of these languages? Why all of these things, right? Because, you know, you look at what we've been telling you guys about Metro-style applications is that, hey, you know, you can go off and build these things in effectively almost any language that you care about, right? You know, there's an awful lot of variety across, you know, that spectrum of languages, right? From JavaScript to the .NET languages to C++. And there's fundamental reasons for this, right? Because what we tried to do at Microsoft in building Windows 8 was this whole reimagine the operating system, right? So we had this opportunity to create a brand new platform. One of the problems whenever you create a brand new platform, right, even one that's built on top of the foundations of an existing one, is the fact that you need people to build applications for it, right? And in order to get people to build applications, you have to try and remove as many roadblocks from them building an app as possible. Right? So we had to do an awful lot of engineering work here, right? I just want to make sure you guys understand that, so that, you know, the Windows team could build APIs, right? Which is, you know, what the Windows team is supposed to do. But those APIs would be available to you in all of the languages, right? Because you know about, you know, the way we used to call Windows APIs in the old days, right? Be it with VB6, right, and doing all those crazy things that you had to do with importing DLLs to, you know, the pinvoke stuff that we did in .NET, right? It was all painful, right? There was this whole kind of moment. What we wanted to make sure with WinRT and the WinRT APIs was that these things were going to be natural and familiar to you, regardless of what programming language that you use, right? So if you're a JavaScript guy, you can go off and new up an object, and you can new up this object, and you can do stuff with it. And it's going to feel like it's a JavaScript object. If you're a C++ guy, right, you can do exactly the same thing, right? You can new up one of these guys, you can manipulate its methods and properties, you know, just like it were some other C++ object, and the same thing with .NET. The other thing that was very clear was that the Windows team couldn't afford to build 3 sets of APIs, right? We couldn't build a .NET set of APIs, a JavaScript set of APIs, and a C++ set of APIs. There's one set of APIs, one set of code. We write that all in native code, right? Write that all in C++. But all the other languages can consume it. So that's what my team was responsible for. My name is John Lamb. I work on a team called the Runtime Experience team. And what we did was we kind of created the plumbing and the foundations for what we would call WinRT today. In fact, we created the name too. And you know, when we created this technology, we had to make sure that, you know, we could get it out to all of our partners, which is all the other teams in Windows, all of our language partners. And we defined what the contract was between the components that the Windows team wrote and each of the language implementations, right? So here's the contract, you know, Mr. JavaScript guy or Mr. C++ language guy, right, or Mr. .NET guy. And what they did was they did all of the plumbing, right, that will plumb their language semantics onto the mapping for us, right, which will automatically translate the stuff into the WinRT thing. So you as a developer generally don't need to know anything about the underlying implementation of how we built the WinRT objects. themselves. Right? Have you guys done any kind of digging at all into this thing? There was a great talk by one of the guys on my team, Matt Mary, from the Build conference, right? Where Matt goes into a lot of detail about how all of this stuff actually works, right? And, that 3-letter word was mentioned there, right? COM. Right, so underneath it, there's plumbing in there, right? But we had to bootstrap this stuff in a hurry. The reality is you'll never have to see any of this stuff, unless in some certain scenarios, such as you're programming directly in what we call low-level C++ without using all the new fancy C++ syntax. And there you're going to see that stuff, right? But short of doing that, you'll never see this stuff. Okay, and that's if you do see that stuff, we failed to do our jobs. Okay, so that's kind of the why of what we have, and of course, the goal was to do that, right? Now, what we fundamentally created was these two things, right? We created this WinRT thing, which, kind of loosely speaking is, my team built the stuff which makes it possible for you to create new objects, right? That's thing number one. And the second thing that we did was we defined what this SDK was, right? And as part of this definition, there was a question just before this talk, about so why are a bunch of these kind of legacy APIs not there, right? Why is create thread there? Why am I not allowed to call this API? And the reason is because this is a brand new platform. There aren't any existing applications on this platform to break. Right, so we have this opportunity to shrink down the surface area of the API set. Right? Win32 itself has hundreds of thousands of APIs, literally, today. Right? It's very, very hard for people to understand, especially as these things evolved and things were replaced, and nobody ever says, well, don't use this one anymore. You use, people kind of generically know this thing, right? But the docs certainly don't tell you this. Right, so we have this opportunity to shrink everything down, force you to validate against a tool that you'll see later on in this talk, which we call WAC, right, the Windows Application Certification Kit. Which will do static analysis over the code that you wrote to make sure you're not calling any APIs that are outside of the set. Right? The store will reject you if you do that. But this is a nice opportunity, right, for us to slim down the platform. We can grow it again over time. Right? So this is, again, this kind of generational shift that we have there. So that's the foundations of what we did. Why do we do some of these things? We've talked a little bit about some of these things. We want you to easily create apps. We'll talk more about that in a minute. Not only do you want to create apps, but we want you to create apps that aren't these kind of lowest common denominator apps that, like a web application. Web applications are a great example of a lowest common denominator application, right? They're trying to use resources available everywhere. We really want you to take advantage of things that the user has on their machine. Do they have sensors? If they have sensors on the machine, you want to be able to use that. If they have local documents and files that they want to access using your application, you should be able to access those things as well, right? So those are the kinds of things, and we'll see some examples of that in our talk. And then finally, inside of the tools, we wanted you to be able to create these high-quality applications. We'll take a little bit more about what that means in the debugging experience and the error handling and things like that that are inside of the platform. So as part of this easily creating apps thing, there's two kind of key things, using what you know already and using what you have. Right? So using what you know is this kind of language skill. Like I know something about languages or I know something about some rendering technology, right? Maybe it's HTML, right? Maybe it's XAML, maybe it's DirectX. Using what you have is code that you have already, right? Sometimes it's third-party code, sometimes it's existing libraries that you have. When we go off and we talk to app developers, right? And by app developers, we mean the Instagrams of the world and the Evernotes of the world and those guys, right? What you see is all those guys realize they live in a multi-platform world, right? That's just the way the world is today. And because of that, they need to go off and create applications that run across all of these different platforms. They're very, very concerned about code reuse, right? Because as they add new features to their app, right, they have to add it across n different platforms that they need to support. So if they have this ability to share code across the platforms while still targeting each platform, trying to extract as much out of each platform as possible, that's where everybody wins, right? The consumer wins and they win because they get good reviews in the stores and that kind of stuff as well. So that's a very important thing. A lot of times people pivot around perhaps a little bit too much the language aspects of things. Like, oh, I like to identify myself with a language, right? As opposed to, let's think a little bit about what the application is that you're trying to do is. If what you're trying to do is you're trying to render some kind of rich flowing text layout with images and media inline inside of that, HTML is a fantastic platform for rendering that stuff, right? If you're doing something more akin to a line of business application where you have controls and grids and that kind of stuff, right? XAML is a great platform for that because there's lots of existing toolkits that exist inside of that world. If you're building a game, right? DirectX is a fantastic platform for that as well. And not only can you just use them for those particular scenarios, you can also mix and match this stuff to a certain extent, right? And we'll talk a little bit about the mixing and matching of it as well. Because one of the key things we'll see today in the application that we build is you can build a hybrid application. And a hybrid application is an application that says, hey, you can go off and build something in technology one, right? So in our case, it's going to be an HTML JavaScript application. And you can also mix and match a bunch of C# code in with that as well. You can also mix and match a bunch of C++ code in with that as well. If you take a look, in fact, at one of the applications, so that's the language mixing. There's a rendering technology mixing that's possible as well. So we go over here and we look at the Bing Maps application. The kind of cool thing about the Bing Maps application is, you have this great kind of high performance kind of zooming and scrolling thing that you have here, right? What you're seeing here when we're doing that is a direct 2D surface. However, when we bring up the app bar, right, and we see all of those toolbar icons and things underneath, that's all XAML, right? In fact, the little zooming thing, let me go back to showing you the little zooming guy. Go back here. This little zooming thing, the little plus and minus, that's also rendered in XAML, and that's overlaid on top of a direct 2D surface, right? So you get the high performance of the direct 2D surface underneath, right? But also being able to mix and match the XAML stuff on top of that, right? So this is kind of like a hybrid UI application, and there's also these hybrid language applications that are possible as well. Now, not all combinations are possible, right? Because, it would be cool, right? But, kind of C# and HTML might be, right? Could we have done that? Sure, it's a software, right? But the reality is we have to kind of prioritize things so we can actually ship something to you guys, right? So not all combinations are possible in this case. So JavaScript, right, in HTML, that's what those guys are meant to be, right? In a JavaScript HTML application, I can embed C++ components, right? These are these WinRT components that I can build in C++ or in .NET languages, right? VB, C#, right? Both are fine. With XAML, right, I can program that using both .NET languages as well as C++, right? And DirectX is a C++ only technology, right? And that's essentially the matrix, right, that you can kind of think about in terms of languages and rendering technologies that we support, okay? Cool. All right, so let's go back to the slides. Now, the other thing that we want you to do is build apps that use all of Windows. And there's a whole bunch of interesting features that are part of the platform. Contracts, you see, one of the interesting things and unique things about the MetroStyle platform is that, we have this ability to allow apps to share information with each other, right, in very rich ways, right? So it's a sharing contract. There are standard ways that you can invoke things like search, right, across applications as well. Right, so those are kind of the really kind of key innovative things that we have. So contracts are one great way to kind of leverage the other apps on the system, right? Remember, the more apps that a user installs, the better their system gets, right? That's really what we want it to be. If I want to share to Facebook, for example, right? Me, as the app author, doesn't have to figure out how to post things on your Facebook wall, because if the user actually uses Facebook, chances are they're going to have a Facebook app on the machine. So they all have to do is share to the Facebook app, and the app takes care of posting the information onto a Facebook wall, right? So it's that kind of thing where we have the system gets better as you install more apps, right? So that's very important for folks that want to build apps, right? Because you can specialize in building the great thing that your app is supposed to do without worrying about all the other things, right, that might have to go into an application. So we'll take a look at contracts. Capabilities are an extremely important part of what we call the confidence models around applications. So when a user goes up, when my dad, right, goes up, and goes to the store, and he's searching for some app, and he installs an app, we want to make sure the app doesn't do bad things to his machine, right? He's not really going to be in a great position to evaluate an application, right, as to whether or not it's good or bad. You guys all know this, right? You go over to your parents' house or your friend's house, right, and you see, a bunch of toolbars and things inside of their browser and all sorts of weird stuff, right? So, people are really bad at evaluating this, and that's the goal of what the store is all about, right? The store is really all about, hey, you can trust that these things have at least been vetted by Microsoft, right? And as part of this vetting process, your application needs to declare in its manifest, hey, what are the kinds of capabilities that I want to use on the user's machine? Now, you might be a little bit suspicious if you looked at a weather application that needs to have access to your documents, right? Now, maybe my dad's not going to be able to figure that out, but the dude who's evaluating this thing at Microsoft in the store can figure that out, right? To say, hey, a weather app probably doesn't need access to users' documents, so we're going to reject your app because you're declaring a capability, which honestly doesn't make sense for your application. Right? So those are the kinds of things that we get by essentially asking you to do a little bit of work, right? Which is thinking upfront about the capabilities and the minimum set of capabilities that you need in order to do the things that your app needs to do, right? And then you can get that stuff on the store. We'll take also a look at APIs and samples. We'll see that we have a very rich kind of sample infrastructure. And we'll talk a little bit about why we're doing samples differently this time around in Windows as well. Okay, high quality apps. So there's this thing that we've spent a lot of time talking about in this team, and we call it this fast and fluid thing. We really want user applications to not stutter and stall, right? We want to make sure that when you're scrolling and panning things that it's not jittery, right? We want to make sure that if your application is busy doing stuff like downloading a bunch of stuff, for your application or reading a bunch of records off the internet, right? That the user interface doesn't stall, that you don't get that spinning blue donut thing, right? That happens, right, when your application is stalling on the UI thread. In order to do that, we did something that's rather drastic, let's say, right? And you'll see this when we look at the code, is that virtually every single API that you can call is an asynchronous API, right? So all APIs return immediately. You pass the API a callback function effectively, right? It says, hey, when you're done doing whatever it is that you're doing, call me back. And then you can go on and do some more processing once you have the data. It's not like you sit around and wait and block, right, for the data to arrive, right? So that's a key thing. It's a little bit more work for you guys. It's a little bit more complicated. Sometimes when you're debugging crash dumps, you'll be cursing all the anonymous lambdas that you see in there if you program that way, right? But in the end, it's better for users, right? Because they're going to have better applications that don't stall. Another thing is, we'll talk a little bit about onboarding the store. I think we've done that a bit. We'll spend a bunch of time talking about debugging. So debugging, error handling, what happens when things crash, right? Because we know this happens. We know that no matter how much testing you do in-house, there's a certain class of errors that only happen out in the wild, right? And so when things crash out there in the wild, what can you do about it, right? So we'll see that there's a bunch of features that we've kind of added to the platform, which makes it possible for you to leverage the same infrastructure that Microsoft uses to debug crashes that come from our applications in the wild, right? So whenever you opt in, to the, hey, can you send anonymous, blah, blah, blah data, right, to Microsoft, right, whenever things crash, that thing at the beginning of installing different products, that's what that thing does. We have a tremendous amount of telemetry data from applications that tell us why and how something crashed, right? You'll have access to the same data for your applications, so you're going to be in a better position to go off and debug crashes that happen out in the wild in your apps. So we'll see a little bit about, what that looks like too. Okay. All right, so that's enough of that, right? Let's get out of PowerPoint. Let's write some code. Now, before we do that, what I thought would be a good idea is let's look at the end, right? And let's look at the end of what we're going to build first, and so that we're in a better position to understand the application that we're going to build inside of this talk. So what we're going to do is we're going to be building this HTML browser, or HTML editor. It's going to come up. Let's go off and run him. Now, what this application does is it's a syntax coloring editor, right? So I can come over here and say, hey, there's H1, hello world. And when I hit Control Enter there, it just renders all the stuff that I typed in, right? That's what this thing does. It has, this capability. It also has the ability to open up files inside of your file system. One of the kind of cooler things is this thing here he's a zip file, right? So I can go off and open this guy, right? And we can see a slightly more interesting hello world that we have as well, right? So it's kind of neat, right? We integrate with the file system. We integrate with the with Windows. We also support contracts in here as well. So we can come over here and let's go off and bring in search, right? So if the internet's working too, yay, Windows, yeah. Okay, so the internet's working. So over here, right, these suggestions here, as I was typing, they came from Wikipedia, right? And that's what we call a search provider. And it's giving me these search suggestions as I typed. And, there's the, HTML, right, for the Wikipedia, or the Windows 8 article from Wikipedia. So that's what this application does. Now, I realize that you guys are a C# crowd, right? there's a story that I want to tell you, remember, right? Back to, we're spending a bunch of time telling why, right? This is a story which says, hey, we're going to talk about HTML, JavaScript because it's convenient to the story, not because this is what you're actually going to do. We're not recommending that you do this necessarily, right? But what the story says is, hey, there's a bunch of existing code out there. That editor there with all that syntax coloring stuff, I didn't write that, right? I found that on the internet. We're just going to grab some code on the internet, we're going to throw it into the application. Okay? And that's a nice way of kind of illustrating, hey, we can build applications out of stuff that exists today very rapidly by assembling things. Next, what we'll see is when we do that thing where we opened up the zip file, right? The zip file, when things come back, right? That's actually a .NET component that we're going to build, right? So we're going to use that. We're going to say, hey, I can build this WinRT component using C#. We're going to access this zip archive API inside of the .NET libraries so we can manipulate the zip file, right? So there's a good reason to do that, right? We're building an HTML editor. It's probably a really good reason for us to do that in JavaScript and HTML, right? So again, we're picking the best tools for the job and we're combining them together rapidly so we can build an application, right? So that's why, we're building this application this way. Okay, so let's start from the beginning. Now, if we come back over here, let's go do this. Let's open a text editor. I need to type right. Okay. So if we were going to go off and build a text editor, what's the simplest possible thing that we can do? Probably something that, oops, hold on. I forgot to turn on my magic technology. So let me turn on my magic technology. There we go. So I can type really fast. That's my magic type really fast technology. So if all I want to do is build an editor in HTML, this is probably something like what I would do, right? I have a text area. I can type in some text. I have an event handler for, the key up event. And inside of there, when I type this thing, right, I'm going to go off and take the text that was inside of my editor and inject it into the inner HTML property of another div, right? So that's probably the simplest possible thing that I can do here. So let's save this file, and let's start and run this guy. And you'll see that there he is there. And when I go off here and I hit Control-Enter, right, it says Hello World, right? So very straightforward thing, right? That's probably the simplest possible thing that can work. Now, if we come back here, we can, of course, rapidly kind of evolve him a little bit. I can add a little bit of CSS here, right? So if I add a little bit of CSS there, I can change the way this thing looks, and if I just refresh the page, it looks like this now, right? So, it's getting a little bit fancier, a little bit closer to the thing that we were talking about. Now, what about the next thing? What about, I would like to go off and use that syntax coloring thing, right, that we saw there. What you'll see is that there's an existing library out there. It's called CodeMirror. CodeMirror is used by a whole bunch of other editors for browser-based text editors out there on the internet, right? So he's got all sorts of, things for syntax coloring, lots of different languages, right? A bunch of different key bindings. So it's a very full-featured, open source library for manipulating text, right? And all I'm going to do is I'm going to copy 7 files out of its distribution, right? And so what we'll do is we'll do this, and let's copy those files. Let's look at the CSS directory and look at the JS directory. Those are the 7 files that we're going to use, right? So that's essentially, the distribution that we're going to use for the CodeMirror stuff. And let's go back here and let's add some references to that stuff inside of my JavaScript and HTML. Right, so there's my references to the JavaScript stuff. Here's my references to the CSS style sheets that we need there. And I'm also going to add a little bit of other CSS here just to make things look a little bit prettier. Okay. Now, up here, I don't need this text area anymore, right, because we've got a different editor, right? So we have a div that represents the editor now. And I don't need this code here anymore. All I need is that, right? That's the code that tells, hey, CodeMirror, go off and initialize yourself, right? I want you to, turn on line numbering. I want the indent to be 2, right? That kind of stuff. Lots and lots of options if you want to play with this later on yourself. Oh, one thing that's really important that I want to make sure that I don't forget to tell you is that when you go to the download site for this session later on, right? Not only can you watch the video again, but there's this 50-page document that's in there as well. And inside of this document is all of the steps that I did inside of this talk so that you can go home later on, right, and go off and reproduce all the steps yourself, right? So it's better than you trying to, frankly, take notes and random things like that as well. Cool. So there's that. So let's come back here. All we're going to do is hit F5, right? And now we have this guy here, right? And let's take a look at a slightly more interesting hello world, right? So we have that, right? We've got this thing up and running. We can play videos. There's the HTML5 video tag, right? There's a bunch of kind of interesting things that kind of happen, right? So this is effectively an application, right? It does what it's supposed to do. It has HTML, right? It allows me to live preview the HTML as I type it, right? But it's a web page. What we're going to do next is we're going to take what we have here, we're going to turn it into a Metro-style application, right? And as you're going to see, this is very straightforward, right? We're just going to be copying a bunch of stuff, right, into a project that we create. Okay, so let's go off and do that. So let's start up VS. Let's go File, New Project. And let's create a new JavaScript application. He's Metro style, and let's call him Editor. And if I go off and I create this, this application here, and I just go off and run him, all you see is that, right? So this is the default template, right? There's virtually nothing in there except for a little paragraph thing that says put some content here, right, for your application. So that's our starting point for the app. When we come back over here, let's go off and open up the default.html page, right? So this is the HTML page that we're going to do all of our work in. So just like before, right, what I'm going to do is I'm going to take all the stuff in the head section, and I'm just going to go off and type it into here, right? So now what we have is, remember, here are the same 5 files, right, for JavaScript. Here are the same 2 files for CSS, and this is the same CSS that we had before, right, to go off and render things and make it all look pretty on the screen. Right? So exactly the same code as we had in that first app. And over here, oops, let's do that. I have an editor, and I have this guy here, and I need one more thing, which is this div ID is equal to output. Right? So we have that div element there as well. Right? So this is exactly the same application that we had before. Now what I want to do now is I want to come back here. Remember, got to copy the files, right? So let's copy the files over. Right? So I've copied some files into there. But more importantly than just copying the files, I need to remember to make sure to add those same files to my project, right? So over here in the Solution Explorer over there, I want to make sure that I add the appropriate CSS and JavaScript files, right? Because the project needs to know about all of the files that are inside of your application. We'll see shortly why that's really important. It's important, kind of, because it just wouldn't work otherwise. But we'll see exactly why all of this stuff is super important. So let's add those 2 things. Let's go into JavaScript over here, and let's add some stuff over here. All right, so those are just the same files that we had before. And if I go off and hit F5 now, with any luck, we cross our fingers, woo, we've got this app, right? So let's have a different hello world. Yeah, there we go, right? So we have an application that works now, right? So this is the same thing that we had in the previous step, right? Except for the fact that this has now got the kind of Metro style, right? The fonts are now, Sego UI, right? And all that stuff, right? So we've acquired a little bit of the look and feel of Windows, right? But fundamentally, all we've done is taken an existing web app and shoved it inside of a Metro style thing, and it just worked, right? So this is one of the main reasons why I wanted to show off things in this series, right? Because this is very powerful and compelling, right? Is that I can take something that exists already and just basically paste a bunch of stuff in here and just have it work, okay? So now let's go off and do the next step, which is let's integrate this a little bit more with Windows. So let's add some additional stuff so that I can add an app bar with some buttons on it, right? So I can open a file out of the user's file system, right? That's the next thing that we're going to do now. So let me show you a slightly different tool. Let's go over to default.html, and let's go over here and let's click on the Open and Blend option here. Blend is a fabulous tool for allowing you to visualize what's going on inside of your HTML app. Let me show you what I mean. So when this guy wakes up, oh, wake up, please. There we go. What you'll see is it's actually going to go off and render the whole thing here. So let's trim the zoom down here so it just fits in there. So you can see there's this kind of rendering of a tablet there, and my application is actually running live inside of this thing, right? Because that code mirror thing was a programmatic initialization thing, right? So even though it was this programmatic initialization thing, I see a line number up there, there's a 1, right? The gutter is there, right? So this thing's actually live and rendering inside of this. This is a fantastic, fantastic thing, right, when you look at that. So what I'm going to do is I'm going to take an app bar, I'm going to drag and drop it down here, right? So it shows up inside of here. And you'll see that what it also does is it goes off and generates a little button for me, right? So I'm just going to walk up to that button there, and I'm going to change it. Right, let's give them one ID. Let's call them CMD open. That's going to be our open button. And then over here, I say this is going to be the open file icon. One of the cool things about Blend is that when I click on the drop down here, you can also see that it gives me a preview for what the icon for that button is going to look like, right? Something you don't normally get if you're just looking at a text editor, right? So there's a bunch of nice little embellishments there that just make it easier for you to go off and build your application. Oops. So there's open, right? So we got that guy there. Right? Let's close this guy down because we're effectively done here. It says, yeah, this file's changed outside of your editor. Yeah, fine, right? Okay, we'll do that. And you'll see down here that this is the HTML that was written for us by Blend. Right? If I run this guy, we'll see that again, it looks like the same thing before, but when I swipe up or when I hit, the Windows Z button, which brings up the app bar, right, we can see that there's a button down there, right? Our next job there is let's go off and wire up that open button and make it do something. Okay? Let's come back over here. Let's come in here. So up here, what we need to do is, oops, what number am I at? Aha, there, okay. So here's how I wire up the button, right? So when the DOM is finished loading, right, on the page, right, when the onLoaded event fires, what I'm going to say is, hey, go off and find a button or an element whose ID is CMD open, what I typed into Blend, remember. Let's go off and bind to his click event handler, and let's go off and call the open file function. The open file function is right here. Right, so this is what open file does. I want to start off by doing something wrong. Right? As it turns out, that code there is wrong. If we go off and try to run the code that is wrong, you'll see that Visual Studio will yell at you. Right? It goes thinking, getting ready to yell at you. He's getting really angry right now. Right? Watch it. There it is. Okay. So that's what he's saying. Saying access denied. Anyone want to care to venture why access was denied? Yes, exactly, right? I tried to programmatically open a file, right, that was inside of the My Documents thing, and I hadn't declared the capability yet, right? And we have this really convenient little bit of blue text sitting down there at the bottom, which says, stop this and fix it. It's kind of the fix it button, right? Now, lots of people are very tempted just to click on the fix it and go away button, right? But again, this is an opportunity for you to pause and think, right? Does it make sense for my application to go off and access the file system programmatically, right? What we're going to do in the next step is slightly different. We're going to ask the user to go off and tell me what file to open. What this capability is really saying is I could just grovel over your file system and look for stuff. For certain applications, it makes perfect sense. If I'm an MP3 player, right, it makes sense for me to grovel over your music library, right, so that I can find all of your files, index them, so you can have a playing experience, right? That's the job of that app. But for most apps, this is not something that you actually need. And certainly not for this application, right? I'm opening a file. I'm asking the user to go pick a file, right? For that, you don't need the capability, right? This is only for programmatic access to the file system. Right? So let's click on it anyways, right, just to see what happens, and then we'll undo it. Right? Okay, so let's come over here. We'll click on that, and what you'll see is he stops. There's a little star over here on package.appx manifest, and what you'll see over here is that checkbox is now turned on, right? Documents library access, right? So that's not really what we want. I'm going to turn this thing back off. We'll save this thing, right, so that we're not going to be bothered by that. So let's go off and do this the right way instead of the wrong way. So what I'm going to show you next is let's go off and add a few aliases. This is something that you're going to see a lot if you just want to make your code slightly more readable, right? This is kind of like usings and namespaces in some ways, right? Just to kind of make things short so that it all fits on one page. So this is the open file function that I want to show you, which is, hey, let's go off and show some UI to ask the user to pick a file. We've already seen what this looks like, but I just want to remind you right now. If I click on open, right? This UI here displays I can select a file and it opens the file, right? That's what that code does. Let's go back to the app and let's take a look at how it actually does it. So there's the first line of code. In the first line of code, what we're saying is, hey, go off and create this WinRT object. So this is our first exposure to WinRT, right? Remember, up until now, everything's just been all plain HTML, CSS, no WinRT, no Windows APIs involved whatsoever. This is our first Windows API. So in here, we're from JavaScript saying openPicker is equal to new pickers.file openPicker, right? Create an instance of this picker object and then go set some properties on it, right? I happen to be doing this in JavaScript. If you're programming in C#, right, or C++, you would do exactly the same thing, subtly different syntax, right? But that's about it. Right, the operations are very, very similar. So the next two lines are pretty straightforward, just setting a bunch of options inside of the dialog box. Where things get really interesting is there, right? And this is our first exposure to one of our asynchronous WinRT APIs, right? So what we're saying is, hey, Mr. Picker guy, go get a file from the user. Right? But rather than blocking and hanging around and waiting, right, on my UI thread while that thing comes back, right, instead it could potentially go off and do other things, right? We're not doing anything here, but we could do something else if we wanted to. Now what we're doing is we're saying, okay, go pick this thing, but when we're done, right, here's a function, right, inside of here, this stuff in there, indented at that next indentation level, is a function that I want you to call, right, when you're done. And we're going to call, when it gets called, it's going to get called and passed a file object, which gets passed in as a parameter there, right? So you can imagine that, so this is how we do it in JavaScript, right? Because in JavaScript, we're going to pass functions, and the functions get called as callbacks, right? This is kind of just like registering for an event inline and getting, putting the event handler and getting callback, right, on the event. If you're programming in C#, and we'll see examples of this later on when we look at C#, you'll just go off and use the await keyword, right, inside of C# to do the same thing. Right, so there's lots of kind of convenient affordances for you to go off and do this thing the right way. Right, and C++ has its own way of doing this, this kind of continuation style programming. Right, so go off, do this operation, call me back when you're done. Right, is all we're saying here. So that's all I have. So we're done now. We're inside of this next line of code. We get past a file object. A file object is an OS object, right, which represents a file, and you can do things with the file object. So what we're going to do now is we're going to walk up file IO and says, hey, go off and read the text. But remember, it's read text async. Notice that there's an async at the end, right? You'll see this everywhere in our APIs. Anytime you see async at the end of some method name, right, you know you have to go off and pass a continuation to it. And that's the vast majority of APIs that we have inside of the platform. So file IO, read text async. When you're done, here's a function, pass me some HTML, right? So I'm going to get some HTML in here. I'm going to do some stuff in there. Do something, but here's the interesting thing, app.editor.setValue some HTML, right? The text that I got from reading the file was passed to me, right? I'm going to pass it into this thing and set it in the editor, right? That's all I'm doing there. I'm doing one other little thing here, right? And this is a very JavaScript HTML-y thing to kind of think about, right? So let's talk about this, because this again comes back to, again, the confidence model, right, inside of the application. So think about it this way. An application is essentially a package of stuff that you, the developer, created, right, and installed on the user's machine. So implicitly, you trust everything that's inside of that package, right, because you put it there, right? Now, the thing about building applications that can go off and reach out to the internet and download random stuff, right, is that you don't necessarily trust any of the stuff, right, that you got off the internet. And the platform doesn't trust it, right, because this is JavaScript, I can take text off the internet and execute it, right, inside of my page. I can just go off and do that. Right? Now remember, if I were able to just go off and grab some JavaScript off the internet and just randomly execute it, I can access all of those APIs. Right? And imagine that I had the documents library capability turned on in my application, right? So now the bad code can come down, right, and go off and grovel all over the user's file system and send stuff home. Right? That's probably a bad thing. Right? So you don't want that to happen. Right? So we've done a bunch of things deliberately inside of the platform to make it much harder. So somewhere inside of here, right, actually not here, but later on, remember when we hit Control-Enter? Right? What I do is I take the HTML and I shove it into the DOM, right? I set div or the output.innerHTML is equal to the HTML, right, that the user typed in there. And if there was some random JavaScript that was in there that did bad things, right, that stuff would go off and get executed, right? We prevent that when you set .innerHTML, Okay, does that make sense? Right, so we will reject it, and we will throw a runtime error at that time. We'll throw an exception if you try and inject bad HTML when you're doing .inner HTML inside of the web context. We call this thing, sorry, not the web context, we call this a local context. The local context is the part inside your web application that has access to WinRT APIs. We also have this other thing called a web context, right? So if all I want to do is load a page from the internet and render it in the browser, it can do that too, right? But I have to put that in an iframe. And that iframe is in a web context, and that web context has no access to WinRT APIs whatsoever. We can still communicate between the two, but it's much harder. Make sense? So that's what this little .toStatic HTML function does there, right? Is it goes off and does some cleaning, right? It doesn't guarantee anything. It could still fail later on, right? But it does a pretty good job of cleaning up the HTML to remove bad stuff, right? We always verify no matter what. All right, so that's that function. That's opening a file. One thing that's kind of cool that I want to show you now is how this thing runs, right? Because at some point in time, you're going to run into this, so I figure I might as well tell you now, right? So I'm running the application now. What's running it? So let's go off and bring up Task Manager. When we bring up Task Manager, what you'll see is, remember when we were running that web app, which is still running there, that guy there, right? He runs inside of iExplore.exe. Right? That's where all web pages in Internet Explorer run by default. Now notice that our editor is also running, but he runs over here, and he's a new top-level thing. He's got his little icon that sits up there as well. Okay? But editor is also running. Right? What exactly is editor? Let's kind of take a closer look at him. Let's go off and you bring up a Process Explorer to go off and take a peek inside. So if I come over here, let's go off and find proc@. They're not there. We're going to look for this thing called whost. Oops, that's WWA host. www. Stop! Oh, Mark, why can't you let me cancel stuff? I'm going to file a bug on you. Okay, there it is. So we're going to go off looking for this thing called whost. There's whost there, right? And so inside of this guy here, what's interesting about this is, go away, please. Go away. Okay. My machine's just being sleepy. All right. This is what I want to show you here. So the web application that we're running now, right, is running inside of a different host. Right before it was running inside of the iExplore.exe host. Over here, it's running inside of whost.exe as a host. Now, you can see some interesting things. We can see the command line that it was started with, right, using Process Explorer. And we can also see the current directory, right, c:\demo bin debug appx. Let's take a closer look at that directory. So I go off and grab this path over here. Let's bring this thing up, right? So you can see that this is essentially the same directory structure that was in my application, right? Remember how I had to remember to add the CSS files, right, to the project? That's because what Visual Studio does when it runs your application under debug mode is it just copies it into this output directory, right, this appx directory, and points whost at that directory and says, go run it, right? Now, if you're packaging up your application for distribution to the store and ultimately to your customers, what you do is there's a separate packaging step that we'll see later on in this talk. In that packaging step, we package it into a file called an appx file, which is a fancy zip file, right? And we take that zip file, upload it to the store. The store does its stuff, right, to make sure it's okay, right? And then when the user downloads it to their machine, they're getting a zip file. And then whost just gets pointed at that appx file, and it goes off and it runs, right? So that's effectively what happens. You know, when you ship your application, you distribute your application. Okay. Cool. So there's that guy. All right. So let's see, how are we doing there? There's this whole file save part. It's all documented in gory detail right inside of the document, right? It's not super interesting. It's kind of interesting because it shows you how to cache a file and stuff. So I recommend that you go off and read that. But in the interest of time, what I'd rather do is kind of move on to the next part where we get to talk a little bit about C# and .NET. As I said before, one of the interesting things that we can do is we can create these hybrid applications. And a hybrid application is interesting because what we have the ability to do is from JavaScript, go off and call some C# code. Right, directly. That C# code looks just like a WinRT object. It looks like pickers.fileOpenPicker, right? Use exactly the same stuff that you would use to call a WinRT object, even though it's a .NET object that you wrote on the other side, right? As opposed to, in this case, it's some C++ code that the Windows team wrote on the other side. So this is great if you have existing libraries of code that does stuff, right? Whatever that stuff is, right? That you can very rapidly integrate that existing .NET code, right, into your application. Even if, hey, it makes more sense for me to render it as HTML, right? For some applications, it just makes sense, right? For some applications, it makes terrible sense to render it as HTML. Depends on what you're trying to do, right? So this is the kind of key thing that I want to show you next. And as it turns out, it's very, very straightforward for you to do this. In fact, you probably already have all the skills that you need, right, to go off and build one of these hybrid applications. So let's start off. We'll go up here, solution. We'll add a new project to this guy. Inside of this new project, what we'll do is go to C#, Metro Style, Windows Runtime component, right? So we're going to use that template. And we'll say, here's a zip, right? Go off, go generate some stuff, and there's the default file, right, that gets generated in this case. Let's get rid of the boilerplate. Let's put in my code, right? It's 59 lines of code, not very much code, right, that does this thing, right? The key thing that's really kind of interesting is this guy here. This is the API. Notice he's a static method, right? So he's a static method on a WinRT class, and he's public, right? And if you look at his signature, he goes, he's some iasync operation of string. Right, this is an asynchronous API as well, right? So the cool thing is that, well, you just squint, look in there, he returns a string, right? That's what he does, right? So he's going to go off and read the first file out of a zip file that was passed to us. This is a WinRT object. Remember that file object that was passed in originally that came out of that file open picker? That's this guy here, right? He got passed in. I'm going to call some internal thing, right? That internal thing will go off and do something, and it's going to return the string back to us, okay? So that's what this little chunk of code does here. Now, if we go up a little bit, we can see a little bit more about his internal implementation, right? His internal implementation, how many people here have done some C# async programming? A little show of hands. Looks like, about half the people in the room have done some C# async programming, right? So you know that if you're using C# async programming, that, you've got task of T, right, is the signature, right, for your asynchronous functions, right, that you're writing inside of C#. So what we have is there's an async task of T. So here in this private function, it's all C#, right? This is all existing C# stuff that you know, right? And all we're doing in here is we're going to copy something to a memory stream. We're going to go off, and behind the tooltip is a zip archive thing. We're new up a zip archive object, right? The zip archive object will take the memory stream, create an archive, make sure we have at least one thing, and then we're going to copy that stream to a string, right? That's all we're doing inside of here, right? Nothing fancy. Right? I'm just taking the first file, assuming it's HTML, and copying it out there, right? Because I didn't want to create more UI, right, in the app. So that's all this guy does. Now, the last interesting little piece of code that you're probably wondering about is this, right? As async operation, right? So this is an example of technologies that were built at different times, right? All of the .NET async stuff was built before any of the WinRT async stuff, right, by different teams, right? That's perfectly okay. That's just life. And so what we need is, because we have these two async models, we need an adapter, right, that will go off and adapt one async model to another. And so there's an extension method that the .NET guys created, .asAsync operation, that you can use against a task of T, right, that will convert it into an iasync operation of T, right, so you can return it back. Right, so that's how this is the pattern that you'll see, right, is you'll have some public function. Public functions inside of one of these WinRT components are automatically exposed, right, to any WinRT client, right, so that you can call them. Private things are not, right? You can go off and call those things, and you just delegate it to some private implementation that does the thing that you want, right? So that's the pattern. You'll see this over and over again when you do this. So that's the code, right? That's the C# code that we have for opening a zip file. Let's go back to the JavaScript code. And, oops, it's up here. And instead of this function here, let's get rid of that, right? And, oops, let's go off and drop this guy in here. Oops, hold on, I'm confused. This is what happens when I can't remember what number I'm on. There we go. Okay, so this is the new implementation of OpenFile. And the only thing that really changed here is I checked to make sure the file type is a zip file. And if it's a zip file, I'm going to go off and delegate the call to zip.zip.read first file, right? There's namespace, .class name, .static function name, right, inside of there. So that's what we do, and everything else is the same as we had before. Right, so now I've got some .NET code that's integrated in with my JavaScript code. I'm calling it transparently from JavaScript to .NET. One last thing that we've got to do, right, thing we always forget when doing this stuff is got to add the reference, right? So go over here, we'll add a reference, and node extensions inside a solution. There's zip. We'll say OK. Go off and hit F5 now. We'll run the application. Thinking. And let's bring up the bar here. We'll see that the zip file now appears, right, because we added the zip file also to the list of files that we wanted to filter by. I can click on that guy, and he goes off and he opens and he loads the HTML, right? So pretty straightforward, very simple way for you to kind of integrate, you know, two different technologies, right? So code that came from different places, right? Some existing code in the .NET libraries, some existing code inside of CodeMirror. We can glue them all together using WinRT, right? Very, very fast as well. So that's what we did to get to this stage. Now, you're probably wondering, okay, so now I've got code in two different programming languages, right? How do I debug this? Let's take a look. Let's drop an F9 breakpoint here and another breakpoint down there. Right, so I'm dropping a breakpoint before, oops, not here. I'm dropping a breakpoint before I call into my .NET thing. I've got a breakpoint after I return from my .NET thing. Let's just go off and run this guy first. And I also want to debug the .NET thing. Right, so I'm going to show you the little trick. Sadly, it's a trick. You'll need to know the trick. We'll open up another instance of Visual Studio. File, recent projects, editor. And let's open up the .NET code inside of the solution here. Yeah. Let's go down here. Let's drop a breakpoint on this line here. And now what I'm going to do is I'm going to go to debug, and I'm going to attach to process. I'm going to come down here. You can see there is whost.exe, right? And you can see that editor is there as well, right? So that's the editor process that I want. I'm going to go off and attach him to that process. I've got two debuggers now, right, attached to the same Win32 process. So I come back over here, go off here, click on open, right? Pick the file, right? Now I'm sitting at this first breakpoint, right? You see that? Okay. I can inspect things, or I can see what this file object is, and blah, blah, blah. All the usual things that we can do inside of the debugger. I'm going to hit F5 now, and boom, I'm sitting inside the other debugger, right? So I'm now in here, I'm doing this, and all this kind of stuff, right? I'm stepping through the code. Hit F5 again, I come back out to the JavaScript debugger, right? See how that works? You're saying, but John, why do I need two debuggers? Right? Why did you do all this stuff? Because it's really, really hard to create unified debugging, right, across multiple languages and unify what the call stacks mean and everything else, right? I don't know if anyone in the room has ever written a debugger, but some friends of mine have. And whenever I go off to Mike Stahl and say, so Mike, how hard is this really, Mike? And Mike, anyone here know who Mike Stahl is? He wrote a lot of the CLR managed debugging stuff. He wrote almost the entire CLR managed debugging framework. And Mike has this kind of stern face. He's got bushy eyebrows, and he goes, it's borderline impossible, right? You know, he says you can do it, right? But it just takes a lot of time, a lot of investment. Frankly, we had to ship something, right? We had to ship something faster, right? So this is a workaround. This will allow you to go off and actually debug this stuff. Yeah, it's a bit inconvenient, right? You know, but given more resources and time and all that stuff is mostly the time part, right? You know, we can certainly improve on this experience, right? So that's what we have, and this is why, you know, the experience kind of sits today. But it's workable, right? How many people knew that you could attach multiple debuggers to a process? Yeah, a few people, right? Yeah. Yes, that's true. Yeah. Yes. That's right. Yes. So the comment was you can only debug, like, you know, only if there are different types of debuggers, right? So in one case we had the script debugger attached, right? In the second case, when I did attach, I should have mentioned that, but in the attach thing I had manage debugger selected, right, in the options for that. Okay, So that's a debugging thing. Now, let me show you one other kind of interesting debugging story inside of here. Has anyone seen the bug inside of the code? There's a bug in here. I know I threw a whole bunch of code randomly up, typing really fast, right? But there's a bug in this application. Let me show you the bug. We'll hit F5. We'll bring up the open thing. We'll click on the open thing. I'm going to hit cancel, right? Because nobody would ever possibly click cancel, right? And then boom, right? There's my bug, right? Because I'm not checking the return value, right? And this is a null pointer exception that happens somewhere inside of the framework, right? Because I'm passing a null file object, right, to something. So this is the experience that you would expect if you're doing live debugging, right? So I've got my debugger attached. I hit F5, boom. We see this thing. This thing comes up. When I click on the break button here, we can come back here, click on break. We can go down here. We can see there's this call stack down there, right, which has the context of where the error occurred in my application, right? Now, what happens if I didn't run this thing under the debugger? Let's scroll to the end. Here's the application, right? When you run these apps, it automatically installs it on your start screen as well. So there's editor. Let's go off and run him now. And let's do the same bug. Now, this is the scenario for this is, imagine it's my tester on some other random machine, right, is going off and running my application and decides to go off, come up here, and then click on the cancel button. What you're now going to see is the crash experience inside of Windows. That's the crash experience, right? Because before, we used to pop up dialog boxes with all the totally unactionable things by users, right? Like, what's my dad going to do, right, when he sees a dialog box pop up with access violation, blah, 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 some address and some strange buttons with text that he doesn't understand? Right? Call me, yeah, right? But there's really nothing actionable, right? And that's only if he knows me, right? But the app developer, I'm not the app developer. I have no idea. I can't fix it. Right? So what you really want is that information to go back to the application developer, right? As opposed to being displayed to the user. So this is why the conscious decision was done here, right? That when an application crashes, we just throw you back to a friendly place, right? Which is a start screen on your machine. Same thing happens in other platforms, right? Other platforms do exactly the same thing, right? App crashes, you're not going to throw up some random dialog box that the user can't do anything about, take them back to a safe place, okay? So, but is all lost? How am I going to figure this out, right? Let's go take a look at the information. So from the keynote yesterday, right, we had this, this cool thing where you can right-click on the corner. I didn't even know about this, right? Event Viewer is down there. And over here, Application Services and Logs. Thinking. Why is my machine running so slow today? Okay. He's just tired. It's been a long week for him. So there's app host. Inside of this thing here, you can see that I have this error. Now, this error is incredibly difficult to see, so I'm just going to paste it into something so you can see it a little bit bigger, right? Apologize for the formatting. But you can see at the very least, right, it says, hey, it crashed over in this file, that line, that column position, right? So at least you have, you'll know to look in the event log, number one, right? So if this happened locally before you shipped it to a real customer, this is your local tester, you can go off and look at the event log under app host, right? You'll see an artifact of an attempt to rename stuff, right? It was wahost. You saw wahost.exe was the exe, right? And this thing's called app host, right? So we have that. And so there's default.html there. We're going to take that same information. Now imagine that you were a developer of the application, right? Logged into your dev portal. Right? You're going to see, oh, your app crashed, right? And we'll give you this information, hopefully formatted a little bit nicer than this, right? Up on the portal. Regardless of formatting, you have the thing that you need. At least you know the file, column, line where the exception occurred and the type of the exception that happened, right? So we're going to send you some of the telemetry back. So this is what you get for JavaScript. We'll see in a moment that you'll get a bit more if you're using C++. Cool. So there's that. Now, for the final thing that I want to show you, the last little piece that we have in our application was integrating the search contract, right, into the body of the application. Let's see what that looks like. Now, if you're like me, right, I didn't work on the search contract. I had no idea how this thing works, right? That's some other team that built that thing. In the early days, when inside of the team, when we're building our own little play applications at Microsoft, it was like really frustrating. You have to send email, right, to some giant list with 3,000 people on it. It says, hey, how do I do X, right? And somebody comes back and says, this is how you do X. What we have is the kind of collective wisdom of that list, right, and a set of samples that we created for the product. And you can see under the help menu, there's a samples button that you can click on, right? And we've integrated samples directly into the essentially new project or open project dialog box, right? So you can now open up a project, a sample that's out on the internet somewhere, you'll download it, install it, right? You can open it directly. We're going to see that in a minute. When we built samples this time around, we held samples to an extremely high bar. Like if you're, I don't know how many of you guys work at companies where you deliver things to people and part of them are samples and stuff, right? But a lot of times samples are treated as kind of second-class citizens, right? Well, we'll do them when the product's done, right? It's kind of like docs, right? And this time around, we didn't do that, right? We held samples to the same bar and quality bar as we did with the product code. It gets checked in, it's in our build system, it all ships at the same time, right? None of this, teams are going to, oh, we'll just wait until the very end, right? Then we'll do this stuff, right? Teams have to plan for this stuff ahead of time. That's why we have somewhere in the neighborhood of 400 and change high-quality samples in all the languages available up on the Dev Center now, right, for release candidate. So let's take a look at one of them. So let's go over to search, or samples. Right, so this is the new pane. I'm just hoping the internet here keeps working. Please keep working. Hope that guy is still holding the two things together outside. Yay! It works. Okay, so I can search this guy, so I can say, okay, let's go off and find the search contract. I hit there, he's going to go off and do the search. And there's a search contract. You can see there's a version of it for C++, one for C#, and one for JavaScript. Right? So let's go off and grab and open this guy here. Notice that he's going to drop that thing there. Let's put him in the temp directory. Let's say OK. I'm going to close this solution down. And he goes off, and he's now displaying this is the doc page, right, that was up on the website, for what the sample does. It kind of describes it. But the cool thing is the whole sample's here, right? So what can I do? I just hit F5 to run it. You'll see that all of our SDK samples all have a very uniform look and feel. One of the challenging things about samples in general, right, is that people generally write some arbitrary scaffolding to show their thing, right? And each team does some arbitrarily different scaffolding to do their thing. And so, it makes it hard for you as a developer because now you got to parse through all the scaffolding, which is arbitrarily different from team to team, right? In our case, what we did was we had a standard template that we made everybody use, right? All 300, 400, or however many samples there are, right? All use exactly the same template, so you can reason about it. Once you understand the layout of one sample, you understand the layout of all of the samples. So what we have over there on the left-hand side is a bunch of different scenarios, right? So kinds of things that we want to do. As it turns out, scenario number 5 is the one that we care about in this case. So scenario 5 is, hey, suggestions from open search. So pay attention to the green text, right, as I type. So if I come over here and do, the thing to bring up the charms and there's search, right, you can say hello world, right? You can see as I'm typing hello world, the green text is changing inside of my sample. So what this is telling me is that, hey, as I'm typing stuff, right, what Windows is doing is it's feeding, right, the text that I'm typing in the search box to the application. The application can do stuff with it. Right, so it can go off and implement some kind of incremental search. This thing here, suggestions from Open Search, as it turns out, a bunch of sites on the internet have implemented a protocol called the Open Search Protocol. And what all this is a very simple REST-style protocol where I say, hey, here's a query for foo, right? And the site just returns me back in a JSON file, a list of suggestions, right, that begin with foo, or maybe that have foo inside of it. It's up to the site to implement it how they wish. Right? So that's the code that we're going to get. If we look inside of this, remember, he's scenario number 5 here. Right? Let's come back over here. And we go over here to JavaScript. There's scenario 5. We scroll down here. Turns out that it's this code that we want here. Right? And not only is it this code here, but this suggestion URI is going to be the thing where I'm going to replace that with a pointer to Wikipedia, right? Because remember, we're pulling our search suggestions off of Wikipedia in this case. Okay? So let's go off and do that. Switch back to my sample. And up here in the app on loaded, right? I'm going to go off and insert the code that I need to do the right thing now. So this is my search suggestions code. This is remember we took a look at this, right? This is exactly the same code that we had before, right, out of the sample, right? I just pasted into the app on loaded thing. And let's see, I'm going to need to drop this guy up here. And I need the Wikipedia URL, right? So I need to put him in there. So there he is there, right? So that's the search URL for Wikipedia. And I just need to uncomment this one line of code there, right? Which will append the query text to the end of that URL that I'm going to send off to Wikipedia. Rest of the code below, all it does is goes off and parses and does the right thing and fulfills the contract, right? Retrieves the JSON from Wikipedia, right? After it retrieves the JSON from Wikipedia, it goes off and adds it to the search suggestions as part of the search contract, right? So the things that we see that show up on the right-hand side under where I'm typing, right, over in the search bar, right, that's where all the stuff comes from. The app is actually responsible for going off and sending that information back to the charms bar. So now we have this. There's one last thing, which is what happens when the user hits enter, right? So when the user hits enter, you're saying, okay, now execute this, right? This is the thing I want you to get now, right? So when your application is activated, it can be activated for a couple of different things. In this case here, it's being activated for launch, right? So it will tell you, here, activated happens. You can check, I'm activated for launch, and this is what happens. This is the kind of stuff that I do, right, when I'm being activated by the user clicking on a tile in the start screen. Let's replace this code with slightly different code. And all we've got here now, same code that we had before, but now I have activation kind search sitting there, right? So now I know when the user hits enter, this code over here gets executed, and all we're going to do is go off to Wikipedia, take what the user selected or typed in over there, replace spaces with underscores, right, and go retrieve the URL. There's a naming convention in Wikipedia, right, which allows you to easily calculate the page. That's all we're doing. So it's kind of cool, right? I was able to just take some code out of a sample, right? Literally just kind of copy and paste. Oh, yeah, this is an important thing. Don't forget this. This is another example of, Visual Studio is mad at you. There's another access denied. So it's like, there's something I need to do. One of the other things we need to remember is in your manifest for your application, you declare a bunch of things. One of the things that you need to declare to the operating system is, hey, I need search integration, right? We haven't done that yet, right? Windows isn't going to go look at your source code to try and figure out, hey, are you, some search contract thing. Instead, what you do is you go off and you declare this. So you go down here and you say search, and you click on add. Right, so I now have search as a capability here. I'll hit F5 now. We're going to run correctly. And let's go off and do the search. We'll click over here. We'll type Windows, right? Windows 8, right? We'll go off and run that. Same thing that we had before, right? It's going to go off to Wikipedia, grab the text, bring it down. Just hope the internet stays working. Yay, internet's still working. Okay. So it was pretty straightforward for us to take that. And you find that an awful lot of the samples contain code that's very simple and straightforward for you to extract, right? Just the pieces that you want, drop it in your application, and then go from that point onwards. Okay? All right. So let's see. One last thing. So one last thing that I want to show you is what happens when you have a somewhat different crash experience, right? So I want to go back to debugging slightly. I want to shift gears back to this. Let's go to C++. Let's create a simple little app. We'll call him Crash App. I'm just going to crash him. I'm going to show you, what the experience is going to look like if this same crash happened on a customer machine for you. And you'll see some of the work that we've done to make this a better experience. So let's bring up the XAML page. Oops. Main page.xaml is over there. Right, he's going to load the designer. And let's go off and, this is a canonical giant button thing, right? Click on that guy. C++ is as easy as VB now, right? This is like the canonical VB demo, right, from 1993, right? Drop a button onto a form, click it. You have to make it really large, too, so you can hit it with your forehead. So, right, so let's write some fun code. Okay? We all know what that code does, right? So we'll go off and run this. Oh, yeah, we have to build it. So we'll build, we'll run. We'll click on the button. And when we click on the button, right, inside of the debugger, you're going to get what you probably expect, right? It's going to stop. It's going to say, hey, would you like to break? You'll see the call stacks, right? You inspect locals, all the typical things that you get out of live debugging. And as we're going, need to tap a little bit. Here we go. So click on the button, right? We stop here in the debugger. We break, right? I have my call stack, right, sitting down here, right? Here, quick, memorize that. You'll have to remember that. We'll see it again in a moment, okay? So there's what the call stack looks like, right? So there's a local crash. We know how to deal with these kinds of things. Now, let's imagine instead that we're on a user machine, right? Or on your tester's machine. And they went off and launched Crash App. And they're going to click on the button. Before I click on the button, I want to show you how I've prepared this machine specially for this. There's a fantastic feature in Windows called local dumps. How many people have this feature enabled on their machine? See, nobody knows about the existence of this feature. It's a fabulous feature. What this feature does is it says, hey, when an application crashes, go take a dump of the memory. And the dump is essentially, by default, you can configure it using the options in this, right? But you can configure it so that, hey, you know, by default, it just goes off and says all the current active stacks, right, go off and take a snapshot of all the stacks, right? That's all it does. There's no heap, there's nothing else. But generally, if you have stacks and locals, right, that are value types, right, you'll have some hope of at least debugging what happened, right? You'll have the type of the exception that happened, right? So you have quite a bit of information, right? Certainly more than, you know, nothing. User calls up and says, it went away. I saw my start screen when I clicked on the button. Now what? So let's do this. We'll click on the button, right? He goes off, he crashes. Let's go back and let's go off and open my temp directory. You'll see I crashed it yesterday, right? But here's the crash from today, right? Because today's the 28th. Let's double click on this guy. He'll open up an instance of Visual Studio. Visual Studio will go off in a second. Right? We have this debug with native only option over here. I click on that, and what VS does is he goes off and creates a new process, loads the crash dump into that process, and sets the instruction pointer to where it's supposed to be and crashes it again. Right? So we have the same stack over here as we had before. And you'll have, no, right, you know, you're going to have some limited debugging ability, but this is a lot better, right, than just, hey, you know, the thing just went poof and went away. This is the experience for x86 and x64. Okay, so on x86 and x64, this is going to work just fine for you. If it's ARM, though, right, so if you're building stuff for ARM, right, and this is, again, one of those things where, hey, in an infinite amount of time, right, infinite number of monkeys, we could create any debugger we wanted. In this case, well, we didn't have an infinite amount of time or an infinite number of monkeys, so what we did instead was we had a compromise. Compromise is, how many people here use WinBag or WinDBG, right, as their debugger, right? So there's a few of you guys in here as well, right? So WinBag can debug ARM dumps just fine, right? So you'll have to open up those dumps in WinBag instead of inside of VS. Okay, so it's not horrible, right? So said, but for the people that might need to do this that don't use WinBag, well, it's a great opportunity for you to learn how to use WinBag, right? So that's that. Let's see. So I think we're at the end of the coding part, and I have all of 2 minutes left to wrap up. So remember, right, just to kind of summarize where we're at, we started this thing by talking about why we created this platform, right? We wanted you guys to go off and build apps that run on top of Metro-style stuff, right? We really need your help. We tried to do everything that we could, right, given the constraints of real engineering, right, to give you guys the best set of tools to go off and build those applications. I think that with the hybrid apps and being able to reuse chunks of code that you have before, right, you know, some C++ libraries that you might have around or some C# libraries that you have around, or maybe you want to go off and take an existing XAML app that you have and get it to run on the WinRT flavor of XAML as well, right? There's any number of options that you can choose to do, right, inside of this world if you're bringing apps into the Metro-style world. We also give you a fantastic distribution opportunity with the store, right, to reach, well, we've sold 650 million licenses of Windows 7 so far, right, you know, 375 million PCs are going to be sold next year with Windows on it, right, so that's a fantastic opportunity, again, for people to consider, right, that there's this big market that's kind of waiting for you to go off and build these applications. So that's that. Remember, don't forget about the PDF, right? Feel free to download it. As I said, there's like 50 pages of detail, right? You know, so you can go back and review the stuff that you had inside of there. There's pictures of cats and stuff in there too. And there's the related sessions, and of course, track resources and stuff. And then there's like this thing, right, where we have to beg for evals, right? So don't forget about that one, right? Because this is important to us because this determines whether or not we come back, right, to talk to you guys again. So I think we're right at the end of time, but thank you guys very much for your patience. Certainly yesterday. Apologies on behalf of the organizers for having too small of a room. I have one favor to ask for you guys before we go. Any chance we could turn up the lights in the room? Yes? No? The team doesn't get to come, right? I work the Runtime Experience team. We're about 50 people, but the DevX team is a lot bigger. This will go out to the DevX team, it's about 500 people, right? They don't get to go. They don't get to see customers. They don't let us out of our cave, right? We kind of work in this building, you know, ironically enough, in Windows that has no windows in it. We're in this basement of this terrible place. So what I'd love for you guys to do is just kind of, hold on a second here, just kind of wave and shout and wave your hands and stuff. Say hi to the team, right? Great. Thank you. I know that they're going to like this because this is a, you know, rare chance to have customers say hi and stuff to them as well. So thank you. I'll stick around for a few minutes to answer any questions you guys might have, but it's been a lot of fun. Thank you.